industries, including semiconductors, video compression, and so on. He has held also various positions in industry, from research down to marketing, and at the moment he is Senior Director of Business Development at Qualcomm, Atheros, the networking and connectivity division of Qualcomm. Michael has a Bachelor of Science in Electrical Engineering from MIT and a Master of Science in Stanford. Yeah, the floor is yours.
Thank you. Thank you for coming this morning. So I'm going to talk a bit about some connectivity issues associated with smart TVs. If you've been around the show floor at all, you see there's quite a move to adding connectivity to TVs. And there are some issues involved with that, which the industry is working on solving. So what's really driving connected TVs? Well, consumers are very interested in consuming content more places and more devices at any time, both mobile devices and fixed devices like TVs. I think a good indication is Cisco has a video networking forecast that they revise every year, and the current one is shown here, and you can see the growth in internet video as a percentage of all internet traffic is just phenomenal. I mean, it's going to be almost all video at some point. So this is a lot of content that's coming largely into the home and also to mobile devices for folks who are out and about. Now, once you get inside the home, it's getting really crowded there. There's more and more connected devices that are fighting for bandwidth. And so typical home networks are being really stressed by a lot more devices and a lot more content. If you look at a typical video operator in the US, they push four TVs and 4 HD streams with PVR capability and trick modes, and it just puts a lot of stress on the network. We see that in a few years, typical homes could have as many as 100 IP addresses, not just media devices, but also appliances and thermostats, lights. Everything's going to be connected. So there's a lot of bandwidth needed to support these applications. So here's some typical requirements for a video service operator. With compression getting a whole lot better. Oops, the wrong button there. Most guys are down under 10 megabits, although there's still a lot of 20 megabit video, MPEG-2 flying around out there. And typically they want at least 50 megabits of coverage everywhere in the home, and that really presents the biggest challenge. Because they're also looking for low error rates, low jitter, and above all, glitch-free. Consumers aren't used to watching TV that stutters. They want it to be a nice smooth picture. So this presents some challenges, especially as you get more devices in the home. So far, the key or the primary home networking technology has been in Wi-Fi or 802.11, and this is because it's readily available, it's affordable. There's a big ecosystem, lots of devices. It works pretty well, and it's easy to install. It's a no new wires technology, so you don't have to be rewiring your house. But it's a wireless technology, so it doesn't obey the laws of physics, and as your devices get farther apart, the throughput drops. So what we're showing here is a typical house. Maybe it's not typical, but it's a test house that we use, and it's actually a good house because it's very isolated, so it's very RF quiet. So then we can just build up a controlled environment for testing, and we just fill this thing with all kinds of use cases and devices and try to break the network, and then we figure out what the solutions are. So it's kind of nice because it's a linear house. It's a single-story linear house, and actually if you put the gateway over here at this end, which is pretty typical in a house, your DSL and your cable modem comes in at one point in the house. So this has to cover this whole house. And as you go through the house, the attenuations tend to be, they follow these test points. You can see them here. So you can see that this shows a 2x2 11N curve, and this is a 1x1 11N. But let's focus on this one. So you know, when you're in close, you got plenty of throughput, and you got a lot of overhead. They handle lots of interferers and devices. But if I go out over here, if I'd like to put a TV in this bedroom and get content from this gateway, I got a challenge because I just can't get enough throughput there with just plain Wi-Fi. So how do we go about making that better? Well, one thing you can do is you can use more advanced Wi-Fi. I showed 2x2 there because that's the sweet spot right now for Wi-Fi, especially for things like TVs and gateways. So you could go to 3x3 11N, and that gets you, in close it gets you more throughput, but out in the hinterland you get you just don't have enough. Physics comes into play, and you just don't have enough signal. So eventually, all of these the modulations get less aggressive as you lose signal to noise ratio, and so eventually they all operate at the same modulation. Same is true of 11AC, which is the latest 802.11 technology. It's a very aggressive technology. You get very high throughputs when you're in close, but it drops off basically down at the same levels. So in this particular house, even 11AC doesn't help us much, right? So what's one answer? What's another answer? Well, one thing you could do is you could put wireless repeaters, and that's a solution that's used. The disadvantage of that is typically they're just single channel repeaters for affordability, and so every time you do a repetition, you have the bandwidth, so you really waste a lot of bandwidth. What's really emerging in the industry now is what we call hybrid networks, and this is a combination of Wi-Fi and other wired technologies like Ethernet and more interesting lately, Powerline and MoCA, because Powerline and MoCA are, Powerline especially is a no new wires technology. So the idea behind hybrid is that you can, if you have both Wi-Fi and Powerline between two devices, you have a diversity effect. So you can treat both of those pipes as one pipe, and you can intelligently select the right path, best path at any point in time. So there's a lot of work in the industry on developing these kinds of algorithms. And in fact, I'll show you a standard in a minute. So here's an example of some real world tests. This was 80 homes throughout the world, and what we did was we just went around to all the outlets and we measured, well, maybe not all of them, but at least one in a room, and we tried to get Wi-Fi reception there and PLC reception. And you can see for Wi-Fi alone, we're successful 75% of the time. This is over 80 homes. With Powerline, we're successful getting good connectivity 85% of the time. With both of them together in the same spot, it was 99%. And so this is pretty typical of the results you get. So you can see that either connectivity technology alone doesn't really cut it, but when you combine them in a smart way, you can get the kind of results that you want. And so there's a standard that's about to be released, I believe in Q1, and it's called 1905.1, and it combines, so it's Wi-Fi, home plug, which is Powerline, Ethernet, and MoCA, which is medium or coax. This is used largely in the US. It's starting to take hold in China. But the idea is that these PHY layers are abstracted to a higher layer, and we do things like, I showed you how we mix Powerline and Wi-Fi, but you can actually mix all three and treat, use the different ones as diversity. So this is coming on pretty quickly. There's actually, I noticed in the latest Consumer Electronics magazine, there's actually a very good article in there by an acquaintance and competitor, Steve Baum from Broadcom. If you have time, you should take a look at that. It's a pretty good explanation of how this works. Okay, so let's get back to how this helps us with a TV. So if I look at Powerline results in this home, same home, again, I've got the gateway over here. if I look at my power line throughputs at each of these spots, here's the curve. So it stays pretty fat for a while, and then it drops off. And you can see that at 50 megabits, I can get the bedroom floor with 50 megabits, but that doesn't give me a lot of overhead. So I could just run a straight power line to that TV, but a more flexible solution is to use something that's a device that's a PLC plus Wi-Fi extender. So what you do is it's a little device that you plug into the wall. If you get on the show floor, you can see they're all over the place. A lot of companies are building them now. So you plug it into the wall. You get PLC from the gateway to this device, and then it has a Wi-Fi access point in it, basically. And so now you basically restarted your Wi-Fi spectrum. So now this is the Wi-Fi spectrum from the gateway, right? So we saw that before. And if I put this extender in, I can get a much higher throughput out in this part of the house. And this device will because this is higher energy, it'll lock on to that guy instead of this guy. So now I got no trouble getting a video capable signal out to that device. Okay, so we have now reliable networking, much more reliable networking. So now let's talk about how this works with the smart TV. So the way that these smart TVs are evolving pretty quickly is you want to have a very reliable connection back to the smart gateway. So that's the hybrid technology that we're talking about previously. So now I get a good video signal to this TV. But in addition, this enables some new use cases which are really starting to take off, which is now the TV with this reliable connectivity can act as a hub for a lot of other devices around it. So use cases like you walk up to your TV with your smartphone, you're taking some pictures during the day, and you can just throw those pictures over to the big screen and share it with your family. There's a lot of two-screen applications for smart TVs where you're watching something on TV and you're sitting there with your tablet and you go get background on the movie or whatever. You can use your phone as a remote. So there's a lot of applications where these devices just talk directly to the TV. Okay. And so the TV supports that. Sound bar is another one. Putting your audio over to the sound bar wirelessly. So you have these P2P apps, but then also this provides a very reliable conduit back to the internet if these devices want to go get content out there. So particularly mobile devices like tablets and phones, because they're battery operated, they don't generally run at the highest outputs on their Wi-Fi because they want to save battery life. So if you have this kind of connectivity to your TV and just a basic Wi-Fi in here with low power, this device may not be able to get back to the gateway. But if it goes through the TV, it can easily get back there. Okay. So on top of the hybrid networking, there's a couple other technologies that have been developed that also play into this system. One is I'll talk a little bit about stream management. This is a kind of interesting thing. So let's say I have a reliable pipe. I have a reliable hybrid pipe, but I still have a lot of content coming in that at times I can get close to maxing out that pipe. And so I might have a couple of movies coming into different rooms, but I also might be doing just some file transfers and things of that sort. So what stream management does is, if you don't have stream management and you start filling the pipe too much, you start getting latency, jitter, packet loss, and the consumer experience really fades. So with stream management, which sits above the PHY, can work with any PHY, any of those hybrid PHYs. It classifies the traffic. Okay, so it's actually the way that some people do it. The way we do it is statistical. So we can recognize a Netflix stream, we can recognize a Hulu stream, we can recognize a gaming stream. So we can identify these streams, and we keep improving the algorithms all the time, and getting better at classifying the traffic. So now if I know what the stream is, I can prioritize it over other streams. So I can prioritize my YouTube and my Netflix streams over somebody trying to just access a web page or something like that. Okay. So what the user sees is, for video, lower latency video, smoother video, fewer frame drops, fewer freezes, etc. Okay. And here's just one example. This is where we have a router with it's a 2x211N router with the stream management, and then just a regular router without it. And we played this was a 229-second video. With stream management, we had one freeze, and it all played out in 2.5 minutes, so basically real time. With the standard 11N, and this was in a congested network, we had 13 frame freezes, and it took over 5 minutes. So you can imagine how annoying that would be to watch a video that stopped that often. Okay. And then a couple other new technologies that are being put in TVs. In fact, I saw throughout the floor, just about every TV guy has this technology now in their TVs. Now, it's called Miracast, and it's developed by the Wi-Fi Alliance. You won't see too many people calling it Miracast yet because the certification hasn't started. If you go around at the booth, most people talk about it as screen reader because that's pretty much what it is. It was originally developed by Intel, and they called it WiDi for Wi-Fi display, but then it evolved into this standardized technology from the Wi-Fi Alliance. But what it does is it really scrapes your screen. So let's say I have my smartphone and or a PC or whatever, tablet, and I'm playing a movie on it. What it does is it really throws it over to the main TV. And what it does is it takes the bitmap, the image valve, it compresses it with 264 and audio, and it sends it across a Wi-Fi connection, and then it compresses it again. Because every TV can decode uncompressed 264. So it's taken off now because a lot of people have really liked the various use cases that it affords them. So you're going to see this in every TV. And then there's also a technology now called AllJoints. This is an open source technology, which is a development framework to allow developers to easily create peer-to-peer applications without understanding the complexities of the network. So it abstracts all the network complexities. So for example, we could all get out our smartphones here if we all join, and we could directly connect them and play games or exchange photos or whatever. And to write that app is very simple with AllJoints. This is starting to show up in large numbers of smartphones and starting to show up in TVs as well. And then finally, this is something that consumers really like to do, which is media shifting. Probably the best example is Apple's AirPlay. Where you can say on your smartphone, you can find content. It might be on your PC disk, it might be in the cloud, it could be anywhere, but you find it and then you can send it to any device in your house that's compatible with it. So like with Apple TV, you can go find content from iTunes and send it over to your TV or whatever. There's another technology called Skifta, which is very similar, but it's kind of like AirPlay for non-Apple environments, and it's based on DLNA. So any device that's DLNA can work with Skifta. Okay. So to summarize, what you're going to see in smart TVs, I've already seen it, is 2x211N at least for the main connection, and 211AC is coming. We think hybrid will be important, possibly additional 1x1 Wi-Fi to support all the P2P apps, support for Wi-Fi Direct and Miracast, DLNA stack, AllJoints for peer-to-peer, and Bluetooth 4.0 is another connectivity that's now becoming a requirement for 3D glasses all operating on 4.0. Okay. So, any questions?
Okay. Yeah, first of all, thank you very much for this very interesting presentation and the stimulating summary. Yeah, questions, ladies and gentlemen. Let me start with one question. In telecommunications, the telcos are trying to enter the home market, and they call it heterogeneous or multi-layer network. So it's LTE based and so on and so on, and you have macro cells down to femto cells. This may complement your picture. What do you think about that?
Yes, all of those things are emerging and fairly quickly. Many of our gateway customers who use Wi-Fi in the DSL or cable gateway, they're also starting to put femtocell technology. Because then your mobile devices can go direct to the femtocell. It has some advantages. I mean, basically, they're exploring all avenues of additional bandwidth and flexibility. And LTE has advantages, big advantages for certain carriers who may not be as strong in the wired area.
Okay. Any other questions? I think I was very satisfied about this 99% you mentioned by combining the power line with the Wi-Fi. I think 99 is quite nice for home application.
Yeah, it's very encouraging. We're doing a lot of testing right now with algorithm development. The harder part, I mean, doing the basic understanding of it is one thing. Figuring out a way to make it easy for the consumer to decide what they want. Like bring a TV home and they put it somewhere and it doesn't work. What are you talking about? The solution's there, but how do you hook them up with the right solution? It's some interesting issues.
Yeah. Let me thank you again for this very interesting presentation. And this brings us to the end of our session. I would like to take the opportunity to thank all speakers for their presentations, and now it's time to have some coffee.